So we'll calculate the margin of error. So the Z alpha over 2 score value was 1.645 times the square root of 0.498 times 0.502 divided by 1052. So I'm going to put this in as 1.645 times the square root of 0.498 times 0.502 divided by 1052. And we have 0.025. So our margin of error is 0.025. Okay, so we have a margin of error of 0.025. Now we're asked to construct the confidence interval. And so remember, for the confidence interval, if we go back to the slides, we have p hat, which we estimated as 0.498, plus or minus the margin of error, which we calculated at 0.025. So we'll put that together in a confidence interval. All right, so for part C, we're asked to construct the confidence interval. So we want p hat minus e, we want p hat plus e. So remember, p hat was 0.498 minus the margin of error. And if we calculate that up, we have 0.498 minus 0.025, which is 0.473. And we also have p hat plus e, so that's 0.498 plus 0.025. So I'm going to just change that to a plus, and we have 0.523. So we have our confidence in 0.473 to 0.523. Right, so we've constructed that confidence interval by hand. There's also a way to construct the confidence interval using the calculator. So we'll take a look at that. Okay, I'll do it on the computer screen first because it's up, and then I'll go to the TI-84. So here we want to construct a confidence interval for proportion. So I'm going to go into stat, and I want to go to test. And then to test, I want a 1 proportion Z interval. I'm going to click enter. It's going to ask me for X. So X is 524. It asks for n, and n is 1052. It also asks for a 90% confidence level, so I'm going to change my confidence level to 0.90, and I'm going to calculate. So notice my interval is 0.473, rounding to 3 decimal places, to 0.523. It also gives us our estimate of p hat, which is 0.498, which we manually calculate. Now let's take a look at that on the TI-84. So here I have my TI-84. I'm going to go into stats. I'm going to go over to test. I'm going to look for the same one proportion Z interval. I'm going to hit enter. It asks for X, which is 524. It asks for N, which is 1052. I have my confidence level is 0.9, and if I calculate, notice we get the same in 0.473 to 0.523. So I used a one proportion Z interval. Okay, and lastly, we're asked to interpret. Okay, we're asked to write a statement that interprets the confidence interval. So if I go back to our slides, this would be the correct way to interpret it. We should be 90% confident, because our confidence interval was 90%, that from 0.473 to 0.0523 actually does contain the true value of the population proportion. So if we take a look at our answer choices, one has 90% confidence that the interval from the lower bound to the upper bound, which would be the 0.473 to the 0.523, actually does contain the true value of the population proportion. All right, so in this example, we manually calculated a Z interval or P interval, and we interpreted it. We also use the calculator to construct a confidence interval. All right, so if we go back to our PowerPoint, okay, next we'll determine the sample size that's required to estimate a population proportion. And here we have a couple of formulas. We would use the first formula, so keep in mind N would be the population sample size, or excuse me, N would be the sample size for our random sample. N would equal to Z alpha over 2 squared times P hat times Q hat divided by E, which is the margin of error squared. That's if we know P we can find p hat, we can use the formula. However, if there's no estimate for p hat, we would use this formula. The sample size would be equal to z alpha over 2 squared times 0.25 divided by the margin of error squared. So you would use the first formula if p hat was known. You would use the second formula if p hat was not known. So let's take a look at number 33. And in problem number 33, we're given a question. Use the given data to find the minimum sample size required to estimate the population proportion. Our margin of error is 0.008. The confidence level is 98%. P hat and Q hat are unknown. So how can we determine our sample size in? All right, I'm going to go back to our document camera. All right, so this is chapter 7, problem number 33. We have the margin error. I'm just going to write that as E is 0.008. The confidence level is 98%. And P hat and Q hat are unknown. So we have our formula. If P hat and Q hat are unknown, we're going to use a formula. N is equal to Z alpha over 2 squared times 0.25 divided by the margin of error squared. Okay, so in this calculation, the first thing we must do is find the Z alpha over 2 value. So keep in mind we're given 98%, which is not a common confidence level. So we'll have to calculate this manually. All right, so from what we did before, the confidence level is 1 minus alpha. So our confidence level is 0.98. That's equal to 1 minus alpha. I'll subtract 1 from both sides. I have negative 0.02 is equal to negative alpha. I'll multiply both sides by a negative, so 0.02 is equal to alpha. The next thing I'll do is I'll find the Z alpha over 2 value. So I'm going to use that inverse normal. 1 minus alpha over 2. So this is the inverse norm. 1 minus 0.022. And if we use a calculator, and I'm going into distribution, I'm going into inverse normal. I'm going to clear that out. I'm going to put in 1 minus 0.02 divided by 2. My mean is 0. My standard deviation is 1. I hit enter. I'm going to hit enter again, and I get 2.4. 0.33. All right, so my Z alpha over 2 value is 2.33. So in our calculation, N is equal to the Z alpha over 2 value squared, so that's 2.33 squared times 0.25 divided by E. So we were given E as 0.008. We're going to square that. And if we put that into our calculator, we have 2.33 squared times 0.25 divided by 0.008 squared. And we have a required sample size of 21,206.64. If I go back to our problem, we want to round to the nearest whole number, so we would have 21,207. Okay, so again, I'll perform that calculation on this calculator. So we have 2.33 squared times 0.25 divided by 0.0008 squared. I put one too many zeros in there. And we have the 21,207. So we'll return back to the PowerPoint. And now we're basically going to do the same thing, but instead of estimating the population proportion, we're going to estimate the population mean. So before we estimate a population mean, there are a couple of requirements that have to be satisfied. The sample is a simple random sample. The population is normally distributed with N greater than 30. Normally, the standard deviation is not known. When the standard deviation is not known, we use what's called a t-distribution. When the standard deviation is known or assumed, we use a z-distribution or a normal distribution. Okay, so there's a t-distribution that we'll use if theta is unknown, and then there's a normal distribution we'll use if the standard deviation is known. Okay, but normally we don't know the standard deviation. So we have to use what's called a t-distribution, and a t-distribution comes with what are called degrees of freedom. We use n-1 degrees of freedom when we calculate a t-statistic. Once we calculate the t-statistic, we can find the margin of error. So here again, that E is a margin of error, and now it has a formula T alpha over 2 times the sample standard deviation divided by the square root of N. Before we go any further, let's talk about this t-distribution and the degrees of freedom. I want to go to our textbook. And we'll turn the page. I thought I had it up on the window. 318. All right, and on page 318 in the textbook, I just want to talk about this degrees of freedom in a little bit more detail. And it says finding a critical value T alpha over 2 requires the value of the degrees of freedom. The formula for the degrees of freedom are given as n minus 1. Right? So n would be the number in your sample. You would subtract 1. That would give you your degrees of freedom. In general, the degrees of freedom for a collection of sample data is the number of sample values that can vary after certain restrictions have been imposed on all data values. And you're given a couple of examples. But in the definition, notice that it says that it can vary after certain restrictions have been imposed on all data values. Okay, so this has a little something to do with interpretation. I just want you to know where you can actually find this information. All right, so let's take a look at how you would actually calculate a T critical value. So I'm going to return to our homework and we'll take a look at problem number 13. Okay, and I will generate another example. So here it says refer to the accompanying data display that results from a sample of airport data speeds in megabytes per second. So I can see on the right hand side I have a T interval and it's 13.046 to 22.15. So I can conclude that the true population mean is within this interval. I have my mean, my sample mean is 17.598. We have the sample standard deviation is 16.017, and we have n is equal to 50. Now we're asked, what is the degrees of freedom that our T critical value can have? Well, remember from the following information, the degrees of freedom is equal to n minus 1 So in my case, n is 50, so 50 minus 1 would give me 49. Right, so I simply take the value n, which is 50, I would subtract 1, that would give us our degrees of freedom. Now, how can we calculate the critical value for a 95% confidence level? Okay. Well, in order to do that, I'm actually going to use an inverse T. Now, on this TI-83, when I go into my distribution functions, I see an inverse normal, but there is no inverse T. However, on our TI-84, and give me 1 second to bring that up. Notice on our TI-84, if I go into distribution, I have an inverse T. So the inverse T function is what we'll use to find the T alpha over 2 value. So here's what we're going to actually put in our calculator. For our inverse T, we must put in an area. So here's what I'm talking about. I'm in my distribution for inverse T. I'm going to hit enter. Notice I have to put in an area and I have to put in the degrees of freedom. We already figured that the degrees of freedom is 49, so that's my degrees of freedom. Here's my formula for the area. The area is equal to 0.5 times 1 plus the confidence level. Right? So how does that relate to our problem? Well, in our problem, the confidence level was 95%. So for the area, I'm going to put in 0.5 times 1 plus 0.95. I'm going to put the degrees of freedom in as 49. All right. So for the area, I'm going to put in 0.5. I'm going to put in a parenthesis, 1 plus 0.95. I'm going to close off my parenthesis. The degrees of freedom is 49. I'm going to go down to paste. I'm going to hit enter. I'm going to hit enter again. And I get a value of 2.00. So my T alpha over 2 value is 2. All right, so we're actually around to 2 decimal places, so 2.00, we're down to 2. And lastly, we're asked to interpret it. So from our interpretation, the number of degrees of freedom for a collection of sample data is a number of sample values that can vary. So notice this one contains that can vary. This statement does not contain that can vary, after certain restrictions have been imposed on all of the data points. So our correct interpretation here should be C. Okay, so again, you can align this with page 318, and you can see how this interpretation sort of lays out. I'll now go back to the PowerPoints, and here we'll actually construct a confidence interval. So it says we'll use a calculated margin of error we'll use a calculated margin of error along with our estimation for the mean. So we have our confidence interval as x bar plus or minus e, or plus or minus a margin of error. So let's take a look at how a confidence interval for the mean is actually constructed. And in this example, we'll solely use the calculator. So we're going to take a look at problem number 36. Can I actually generate another example? So here we're given that a group of 59 randomly selected students have a mean score of 29.5 and a standard deviation of 5.2 on a placement test. With the confidence of 90% given, we want a 90% confidence interval for the mean score of all of the students. So in this case, the population standard deviation is unknown. We're going to use T interval. So I'll use the calculator that I have on the computer, and then we'll take a look at the TI-84. So in order to calculate this T interval, I want to go to Stats, and I want to scroll over to Test. So notice I have a Z interval, and we would use a Z interval if the population standard deviation was known or assumed. Since we don't, we're going to use a T interval. So once I hit T interval, I'm given the option to either enter in the data or I can put in the statistics. So here I have the statistics. Right, so the statistics would be the calculated mean. So I'm going to put that in as 29.5. The sample standard deviation is 5.2. And N is 59. Our confidence level is 90%, so I'm going to leave that as 0.9, and I'm going to calculate it. So we have the T interval as 28.4 to 30.6 for our T interval. Okay, now showing this example using the TI-84, I'm going to go back to our document camera. And I'm going to go into Stats. I'm going to scroll over to Test. I'm going to find T interval. Same thing, we want Stats. We're going to put in X as X bar as 29.5. We're going to put in the sample standard deviation is 5.2. N is 59. Our confidence is 90%. And notice we have the same interval. We'll also take a look at problem number 18. And in problem number 18, it reads, the salaries of 33 college graduates who took statistics courses in college have a mean score of, excuse me, that would be a mean salaries, I'm sorry, of 60,700. It says, assuming a standard deviation of 12,785, we're asked to construct a 90% confidence interval. So notice that the standard deviation in this problem is assumed. So for problem number 18, we're going to use a Z interval. So I'm going to go back into statistics. I'm going to scroll over the test. This time we're going to use a Z interval because the standard deviation is assumed. We're still going to put in the statistics. So our standard deviation is 12,785. Our mean salary is 60,700. N is 33. Our confidence level is 0.9. And we have a Z interval of $57,039 to 64,361. I'll also do the same thing on the TI-84. So I'm going to go into statistics. We want test. I'm going to select Z interval. I'm going to put in the statistics. So our standard deviation was 12,785. Our mean salary was 60,700. N was 33. Our confidence level was 90%, 0.9. And we have the same interval. Okay, and the last thing we'll talk about is the sample size required to estimate a population mean. So here we have N is equal to Z alpha over 2. So we would have to calculate the Z critical value times the standard deviation divided by the margin of error, all squared. So we'll take a look at problem number 17. And it reads, an IQ test is designed so that the mean is 100 and the standard deviation is 14 for the population of normal adults. Find the sample size necessary to estimate the mean IQ score of statistics students such that it can be said with 95% confidence that the mean is within 8 IQ points of the true mean. Assuming that the standard deviation is 14, and determine the required sample size using technology. All right, so we're going to use that formula. And I'm going to go back to our document. And we had n is equal to z alpha over 2 times the standard deviation divided by the margin of error, and that is all squared. So the first thing we have to do is find z alpha over 2. So from our problem, we were given that the confidence level is at 95%. And if we go back to our notes, so I'm going to switch back to the shared screen. I just want you to know where you can find this information. And if I go to these common critical values, notice at 95%, that z alpha over 2 score should be 1.96. So I'm going to use 1.96 in our calculation. Right. So for 95%, the z alpha over 2 score is 1.96. So n is equal to 1.96 times the standard deviation. And from our problem, I'm going to go back. Right. And from our problem, the standard deviation is 14. And our margin of error would be 8 because we want the sample mean to be within plus or minus 8 points. So the standard deviation was 14. The margin of error was 8. And we're going to square that quantity. So I'm going to put that into our calculator as, I'm going to put a begin set of parentheses, 1.96 times 14 divided by 8. I want to close off my parentheses and square it. We have n as 11.76. And we're going to round that up to the nearest person, which is 12. Our sample size should be 12. And then lastly, we're asked, would it be reasonable to sample 12 students? So yes, this IQ test score is a fairly small number. All right, so that concludes the lesson for today. Thanks for watching.